Hey everyone, my name is Leo. This is for TSM435. This is for our final project. To start off, I'm going to show you guys the circuit for just the Arduino. D2 pin, a 0 pin right here in parallel with the capacitor. And then that goes to ground. And that's pretty much it. It's pretty simple. This is my app right here. The data is already in here, but I'm going to run it again. So this is the background. It just changes it to whatever color we have it there. So you had default, red, green, blue, cyan, yellow, magenta, and white. And you go back and forth to whatever you want. Let's go with blue. Now we're going to run it again just to see what happens. Your DAQ is active. It's acquiring data. And then when it's done, it's going to say ready. And then the light's going to turn off. And bam. Let's start off with these. So the min and max are pretty simple. They're just the minimum and maximum of this graph right here. Whatever point up here is the max. Whatever point that's lowest right here is the min. Sorry about that. The amplitude is just the max minus the min over 2. That's pretty simple calculation. The DC is just the mean of all the individual data points. The ACRMS, you calculate with the DC, you calculate the AC. And then from there, you just root mean square it. Yeah, and then this, the 1 ohm power, this is just, we follow the calculations that were given in the PowerPoint. The frequency and the period, we were given the frequency of 492. And the period, frequency and period have a relationship with each other where frequency is equal to 1 over the period. So that means that the period is really just 1 over 492, or if you put it in decimal form, it's 0.002033. Acquire time is just how long it took to acquire all the data. As you can see right here, it went from 0 seconds to almost 0.12, but really it's like 0.1159. The sample is just a number of samples taken per second. Enter data point, that's how many data points we took. Serial port is which serial port we're using, and then these are just the modes. And these gauges correspond to, this one corresponds to DC, which is right here, and this one corresponds to the ACRMS, which is right here. They're the exact same values, just different ways of showing them. And that is a picture of a line. All right, so this just shows us our signal. This shows us trying to change the signal into a sine wave. So we're going from the signal we were given and trying to change it into a sine wave. These peaks right here are kind of like the noise of of our original wave. And then I'm just going to show you guys if we double the amount of data points right here. It takes a minute again. Green DAQ status is not ready. So here, as you can see, it's still the same graphs and similar data. It's just there's just more points. So maybe the min, maybe there was another min, maybe there's another max. That obviously is going to change the amplitude, and it might change these going forward. But it's just really just more data points to look at. So yeah, I'm gonna change the circuit a bit so we can do the simulations. All right, I'm gonna have to close out of this because I might mess it up a bit, and then I gotta disconnect and connect my Arduino, and then let's run it again. Hopefully this works. It'll take a minute. I guess it isn't. Alright, I guess it doesn't want to do that. Alright, well, as long as it works. So we'll go with yellow. Alright, it doesn't want to work as good as I wanted, but whatever. So the difference between this and real time, and the difference between the simulation and the real time is that in real time we're actually acquiring data from our circuit, and in the 3 simulations we're getting data from a file. So the reason why this one was just like that fast was because it could easily just get the data real quick and just plot it, do any calculation you didn't do easily. Whereas before in real time, it has to actually get the data and then do the calculations. So yeah, as you can see, this is what we got. You can even double it and triple it. And if you triple it, or even if you get even more data points, as you can see, it's even hard to tell like where all the individual data points are at. But you might have noticed that this doesn't really change that much. We'll go into this one. It's a minimal change, but it's there. But compared to this, it doesn't really change as much. So that was the sine wave. So here, just so you can see that real quick, and then acquire data. It's a little different. Before it was kind of uniform. Now it's more jagged, and then as we increase the amount of points we have, it gets even more jagged, and then increase it again, even more jagged. As you can see, there's even more noise as well. And then you're gonna notice here in the sim square wave, it's pretty uniform. I feel like. See, it's a square, pretty uniform. As you can even see if you like kind of zoom in, they're little squares. It's hard to tell, but they're there. And then double it, triple it. It's literally a square. You can't even tell. Now what I'm gonna do is I'm gonna close the program, and I'm gonna go into the Arduino IDE, and I'm gonna change the duty cycle from 50% to about 25. 64. Upload it. It is done compiling, so that's good. So now I just have to disconnect this, connect it again, because MATLAB. Now we're gonna run it. It's there. I'm gonna let it load for a bit, and then hopefully, there we go. It's bigger now. It takes a minute, but it's there. All right, so we're gonna do the square wave. Man. So as you can see, it's a little different from before. Now there's a little bit more spacing in between. There's a bit more noise. Let's acquire data one more time. Again, same thing. There you go, and that's it. We got green, and that's it. That's my final project. Thank you very much.